Hello everybody, today we are going to be discussing the basic terms in geometry. Our goal today is to define the basic terms in geometry. Some of these terms you may have heard of, some might be new to you, but even if you have heard of them, you might not know the definition or the details that we are going to be discussing this year. So our very first term is a point or points, and all this is a location, and it has no size. Okay. And what this is going to look like is just a little dot. Okay? And that might look, something like you've already known this before. Now, the part that is probably going to be new to you is how we name this point. We name this using a capital letter. Okay, so we would call this point A. And when we talk about it, we want to make sure we read it as point A. Okay. The next thing we're going to talk about is a line. And this might sound a little bit familiar. You could probably even picture what this is going to look like. So there's our line. You might remember this has arrows on both ends. Okay. So then how are we going to... there's my back button. Okay. Sorry, I didn't like that those were different colors. That looked funny to me. Okay, so now how are we going to define this line is going to probably be a little bit different than how you've defined it in the past. Because what this line is, it's a series of points that extend in opposite directions without end. Okay, so this is just a series of points that extends one direction, and to the opposite direction it goes on forever. And this is going to be named using you can either name it with points that are on the line. So let me put some points on here so you can kind of see what I'm talking about. So there are how many points on this line? It looks like 3. However, remember a point is just a location. So there's actually an infinite number of points in between points A and B that we actually have labeled on here. Okay, so you can name this line using a couple points, or you can name it using a lowercase, italicized, or cursive letter. Okay, so the way we would name this, we're going to write a couple options here. We could name it line AB. And the way that we denote this is we put a small line with the arrows on both ends over AB. You could name it with another 2 letters, so BC. You could name it AC. And the way that we read this, we would read it line AB or line BC or line L. And technically you don't have to write out line when we're naming it, or L. Just when we read it, we would read line AB, line BC, or line L. Okay? A plane. So a plane, it's not talking about the plane, the one that flies in the air, that you go to Florida in. Instead, we are talking about a surface. There we go. Cool. So there's our surface. And the way that we are going to define this is a flat surface with no thickness. This plane is going to contain many points and lines. within that plane. This plane, this is actually representing my drawing here, the example, is actually only representing a part of a plane because a plane extends forever in all directions. Okay, so then within this plane, let me see if I can, that might make it a little bit easier. Oops. So within this plane, we can have a line. So there's a line. We can also have points. Maybe there's a point on this line and there. Maybe another point over here. Okay. And then when we go to name this plane, you can name it using a capital letter. Again, just like what we did with the point, but the reason this one's going to be a little bit different is we always see it's going to be in the corner of the plane that is shown. Remember how I said that that's not necessarily going to be the entire plane because the plane extends forever in all directions. So we have the name can be a number of different things. We could name it plane P. And notice we're going to write plane in front of this because otherwise how do we know if P is a letter or a point versus a plane? So it can be plane P, or you can name it using 3 points, which is plane A, B, C. And you use capital letters because A, B, and C are all points that are within that plane. Okay, and now that's going to get a little bit finicky on how we are exactly going to be naming things, but we're going to, because that has to get do with some of the postulates that we're going to get into. So, collinear. You may have heard the term co before, like co-workers or maybe co-teachers or maybe a co-pilot. That term co, it means working together or together. So collinear is together on a line. So when we define this, these are points that lie on the same line. Okay, so let's draw a couple lines here. They have to have arrows on the ends to be lines because we're going to learn what they mean if they don't have the lines in just a little bit. So let me put some points on here. All right. Actually, you know what? I want F to be there. Okay, there we go. So we have 7 points that we can see on these lines. However, there are many more because we know that there are an infinite number of points that make up a line. So we can say that A, B, and C are collinear. We can say that D, B, and G are non-collinear. Because there's no way that you can take and connect with a line D, B, and G. That would make like a triangle. There's no ruler where we could take and connect those using a straight line. So those are non-collinear. A, B, and C, we can see all 3 of those are on the exact same line. So those are collinear. Now how about G and C? Are those collinear? from this picture, you might not think that they are, but if I take and did this, let's see. Now, are they collinear? They could be. So that's actually something that we're going to get into in another postulate. So, and that term you probably don't know either, but that's okay. We're going to get there eventually. All right, so let's talk about what coplanar then means. Coplanar is going to be the, it's very similar to collinear. It's just points or lines that exist on the same plane. So let me make sure I have a good color here. Okay, so points and lines that are on the same plane. All right, so let's see here. I'm going to draw a box because sometimes that makes it a little bit easier to see exactly. Maybe there's one in here. Let's see. No. There we go. That's kind of the cheat way of drawing a box, but if you can draw a box, then that's going to help you out. Okay, so we are looking at this box, and if you notice on this box, like this side over here, this is all one plane. Now, this is just representing a part of that plane because remember that plane extends forever in all directions. So let me put some points on this box so that way maybe that will help us. A, B, C, D. All right, so now that our box has some points, we can say, okay, well, the lines AB, remember to put that arrow, the line with the arrows on it above the naming. So lines AB and C, point C, are coplanar. Okay, so let me show you. So AB, so this line that goes through AB, so I can probably put this in a different color so you guys can see. So this line that goes right here, along with this point C, are all on that top of the box. So because of that, they're all coplanar. We could even include in there AB, we could even say AD. AD, the line AD, and C. So now we also have added in this AD because all of these are existing in that top of that box, that top plane. So those are all coplanar. Okay. If we look at the red that I colored in to show you that side plane, these 4 points, D, C, H, and G, are coplanar as well. So those are some examples of coplanar. All right. So what is space? Well, space is just the collection of all points. So it's the set, which means it's the collection of all points. So it's everything. Okay. So that is space. Space is everything. So what is a postulate or an axiom? Now this one might be new. You heard me maybe say it a little bit earlier, postulate. So a postulate is going to be, it's an accepted statement of fact. So what that means is it's just something that is obviously true. I don't have to sit here and try to convince you that it is true because it is obvious. It's obviously true. Now that's where these terms come. The next one is a theorem. So it's a statement that has to be proven. And you're going to learn lots of postulates, lots of theorems this year. Some of those theorems we are going to be proving. You probably have heard a little bit about proofs in the past, maybe from an older sibling or a friend who's taken geometry. Because some reason proofs, they just become a rumor. They get around quickly, but they're not scary, I promise. We will walk through them nice and easily all together. So a theorem is a statement that has to be proven. Okay, and the way that we prove things is we have to use definitions, postulates, and or axioms to prove. Okay. All right, so now we have a couple postulates. So now these are things that are obviously true. And this very first postulate, this is actually one that I mentioned earlier back when we said, well, what about is C and G, are those collinear? And remember, you probably thought they weren't because they had line you could not see, but there was a line. You can just draw a line in that goes through the two of them. Okay, so that's where we talked about postulate 1, because postulate 1, what it says is that through any 2 points, there is one line. Okay, so it does not matter here. I can draw a point A, and no matter where I draw point B, I will always be able to find, oh man, there we go, a line that goes through the two of them. Didn't do that very well, but there we go. Okay, so no matter where I put those 2 points, if I have a ruler or a straight edge, I can connect to the 2 points into the line that goes through the two of them. So there's postulate 1. Postulate 2, that one says, if 2 lines intersect, then their intersection is a point. Okay, so we have a line here. Let me change the color. We have another line here. Make sure that they're lines with the arrows. Okay, their intersection right here is a point. It's a location. So maybe we'll call that point A. Maybe we'll call this line M and this one line N. Remember, those are done in those cursive or italicized letters. Okay, so the intersection of lines M and N is point A. So we can see that the 2 lines are going to intersect at a point. They intersect at a location. All right. Now, I'm going to draw a couple pictures for postulate 3, and then we'll discuss it. Okay, so I drew a cube to represent a couple of planes, and then I also drew 2 planes that are intersecting one another. Okay, so that's what this postulate is. It is if 2 planes intersect, then their intersection is what? So let's take a look at our drawings here. So we have our vertical plane, this one here, intersects with this horizontal plane here. And their intersection, hopefully you can, maybe I can even draw these. So this one, what you see is this top part, and then you can see the bottom part. And then the green will go like this. So here's the horizontal plane, maybe by adding some colors, makes it a little bit more obvious of what we're looking at here. So where does that red plane hit the green plane? And it's going to hit it in a line that goes right there. Let's change the color of that line. So this right here is where they hit. Okay. So their intersection is going to be a line. All right. Now, I drew the cube because sometimes people have a little bit easier time seeing it on the cube, but I'll do the same thing with the colors. So if the top of this cube is a red plane, remember these planes do extend forever in all directions. We're just representing a part of that plane. So there's the red, and then we'll draw a green plane. All right, so we have the red and the green plane, and those are going to intersect. You can kind of see this right here, this line here, is where they are hitting. So that's, again, this line right here is where those two planes are intersecting. Okay. Now, this last postulate in class, we are going to demo it, but for those online students, it's kind of going to be a couple things that we can talk about to help visualize it. Okay, but this one, basically what this says is we're going to talk about a unique plane. And if I had just one point would be within tons of different planes. If I had 2 points, we could think about like a door. A door is usually connected to the frame by a couple hinges, right? Two hinges, maybe 3. But if they were just 2 hinges, that door represents a plane that can revolve in that can represent many different planes, right? But it's still going through those same 2 points if it had just those 2 hinges, okay? But what happens is if you put a third point in there, like a doorstop, then the plane can only exist in one spot, okay? So what this postulate says is through, I don't know why there we go. Through any 3, and this is the key part here, through any 3 non-collinear points, there is a unique plane. Now that word unique means only one. Okay, so this word unique, it means only one. So there can only be one that this would work. So now the reason why I was talking about the door and 3 hinges is if we were talking about those 3 hinges, those would be collinear. And if those are collinear, that door is still going to turn, like open and close on that line. So there are tons of different planes. That door can represent planes in different locations that are still going through those 3 points. Now, in class, we will represent it with a clipboard and the tips of pencils. So one person's going to hold a pencil and they're not going to be able to balance the clipboard. If 2 people hold the pencil, 2 people hold pencils, the clipboard, we can almost balance it, but it's not going to work. It's going to keep falling over. And then as soon as we get a third person, they can kind of put their pencil tips in a form of a triangle and the clipboard will balance. So that's what we'll be doing in class and to kind of represent this postulate. But if you guys have any questions, The next page on this is going to be your assignment. So on the back of your notes, you will actually see the assignment that goes along, with this, with these notes. So if you have any questions, please make sure you reach out and you ask. I hope everybody has a good day, and bye.